Traditional electrocardiogram monitoring in clinical environments typically employs 12-lead ECG machines, Holter monitors, and event recorders. While 12-lead systems are portable within hospitals, they generally weigh over 15 kilograms, e.g., Philips PageWriter TC70 at 15.9 kilograms, require wheeled carts, continuous power supply, and trained healthcare personnel, such as ECG technicians or nurses, to operate. Accurate data acquisition demands precise electrode placement across the chest and limbs, which necessitates formal training to ensure diagnostic validity. In contrast, the KardiaMobile 6L, developed by AliveCor, is a 6-lead ECG device intended for non-clinical users in ambulatory settings. It measures approximately 9 by 3 by 0.7 centimeters, weighs 24 grams, and is powered by a single CR2016 coin cell battery with an estimated lifespan of up to 12 months. The device supports on-demand ECG acquisition and detection of atrial fibrillation, AFib, bradycardia, and tachycardia with clinical-grade accuracy, using automated signal processing and app-based user guidance. No adhesive electrodes, wires, or clinical supervision are required. The KardiaMobile 6L improves upon earlier single-lead devices, such as the original KardiaMobile, and consumer wearables like the Apple Watch ECG. Single-lead systems capture electrical potential between two contact points, typically between both hands or one hand in the chest, providing only a single vector of cardiac electrical activity. This limits spatial resolution and reduces diagnostic sensitivity to conduction abnormalities and arrhythmias such as left bundle branch block or axis deviation. The restricted view may lead to missed or inconclusive findings in rhythm evaluation. In contrast, the KardiaMobile 6L features a 3-electrode configuration, enabling acquisition of 6 independent limb leads: leads 1, 2, 3, AVR, AVL, and AVF. This is achieved through simultaneous contact with both upper limbs and one lower limb. Users place the index and middle fingers of both hands on the top 2 electrodes and apply the bottom electrode to the left lower limb, typically on the medial malleolus or anterior ankle. This configuration approximates the Einthoven triangle, facilitating measurement of 3 bipolar limb leads and 3 augmented unipolar leads. The resulting spatial resolution significantly improves the device's utility in capturing arrhythmogenic patterns and conduction disturbances. The device digitizes analog cardiac signals using a 16-bit analog-to-digital converter at a sampling rate of 300 Hz. These specifications align with clinical ECG standards and ensure adequate temporal and amplitude resolution for capturing key waveform features, including P waves, PR intervals, QRS complex morphology, ST segment deviations, and QT intervals. Bandwidth parameters, approximately 0.05, 150 Hz, support accurate reproduction of all physiologically relevant components of the ECG. Signal transmission is achieved via Bluetooth Low Energy Protocol to a smartphone or tablet running the Kardia application. BLE provides secure, low-power, and low-latency communication while preserving the mobile device's battery life. Data is encrypted during transmission to maintain user privacy in accordance with HIPAA and GDPR guidelines. Upon completion of the 30-second acquisition, the digitized ECG is displayed in real time within the Kardia app interface. The Kardia application incorporates FDA-cleared artificial intelligence algorithms to classify rhythms into predefined diagnostic categories, including normal sinus rhythm, atrial fibrillation, bradycardia, and tachycardia. The algorithm performs beat-to-beat analysis based on RR interval variability, presence and morphology of P waves, PR interval consistency, and QRS duration and symmetry. According to validation studies, the KardiaMobile 6L detects AFib with a reported sensitivity of 98% and specificity of 97%. Users may also opt for cloud-based interpretation by board-certified cardiologists. These experts remotely review the 6-lead tracings for more complex findings, such as multifocal atrial rhythms, ventricular ectopy, QT prolongation, and conduction delays. Review results are typically delivered within 24 hours. This telehealth-enabled feature supports integration into virtual care workflows and facilitates early intervention in high-risk populations. Compared to standard 12-lead ECG systems and 48-hour Holter monitors, the KardiaMobile 6L offers faster acquisition times, greater ease of use, and improved user compliance. Unlike Holter monitors, which require continuous electrode wear and post-processing of long-term recordings, the KardiaMobile 6L provides immediate diagnostic feedback without infrastructure or consumable requirements. Its form factor enables patient-initiated ECG recordings in outpatient, home, or remote settings. A prospective study published in Scientific Reports evaluated the KardiaMobile 6L's ability to measure QTC intervals in 50 critically ill COVID-19 patients. Results showed a mean difference of only 2.9 milliseconds compared to standard 12-lead ECGs, with a standard deviation of 29.6 milliseconds, demonstrating high agreement in critical care environments. A separate study published in the Journal of Cardiovascular Electrophysiology assessed the device's operational efficiency in outpatient clinics and found that its use reduced ECG acquisition time by 30% during electrophysiology follow-up visits, streamlining clinic workflows without compromising diagnostic quality. The KardiaMobile 6L integrates high-resolution ECG acquisition, validated AI-driven rhythm analysis, and clinical-grade 6-lead capability in a handheld form factor. Its compatibility with mobile platforms and user-driven design makes it well-suited for use in remote monitoring, telehealth, patient self-management, and rapid rhythm assessment in both research and clinical contexts.